Hello, I'm Mary Ito, and welcome to the CRAM podcast. CRAM is an acronym for Communicating Research and More, which is what we try and do on this podcast. A lot of exciting research and groundbreaking ideas never reach the public, but they have the potential to change the way we think and act. Well, we're all stressed these days, right? I mean, who isn't, if you ask people? Constant demands made on us at work, at home, financial pressures, obligations to family, friends, and it's all a race against the clock. As a society, we seem to be stressed out. So, what is that doing to us, to our brains? It's a timely and important question, and there's a neuroscientist who's deep in the study of stress and the brain. His name is Jaideep Bains. He's the director of the Krembil Research Institute, senior scientist at the Krembil Brain Institute, and a professor in the Department of Physiology and Pharmacology at the University of Calgary. And he joins us. Hi, Jaideep.
Hi, Mary.
Well, stress really seems to be everywhere. Do you think we're actually more stressed than ever before?
Yeah, that's a hard question. I think we feel like we're more stressed than ever before. I think we live in a world right now where deadlines are pervasive, where we always seem to be in a race against the clock, as you mentioned in your introduction, where we always seem to be trying to get ahead. And so that creates a sense of stress. If we think about stress, the biological definition of it, and that kind of thing, I would say we've been more stressed in the past. When we had threats, like actual threats to our survival, that was pretty stressful. And in our world, we don't necessarily have those all the time.
Okay, so you raise a really interesting and important point about stress as being biological. As opposed to what? As opposed to what other stress?
Psychological, I think. So I would think of it in the following way. A challenge that is presented to an individual from the outside, a threat to you, would trigger a biological stress response. Something happens in your body. Let's say there's an inflammation or you're sick. That's a physiological stress response. But the things that we think about as being stressful, like I have a deadline and I need to get this done, that's a psychological stress, right? So those are two very different things. But the brain has a difficult time differentiating those two.
Okay, so if the brain has a tough time telling the difference, is our body and brain reacting in different ways to those different stresses, or is it actually reacting in the same way?
Yeah, so there's a little bit of both. So your brain, in your brain, there are different neural pathways that are activated in response to psychological and physiological stress, but they're not completely distinct. There are elements that are different, and then there's elements that overlap. And so those overlapping elements are the parts that turn on things like increase your heart rate, they increase your blood pressure, they change your hormone profile in your body. That's your body getting ready to deal and respond to challenges. So those two parts intertwine a little bit. In terms of the pathways that are separate, those are the ones that maybe regulate distinct behaviors, right? So those are separate pathways. But there's definitely a convergence, and that's what makes it challenging.
Yeah. So I think a lot of us, when we think about or talk about stress today, we are talking about that psychological stress, right? Because it sounds to me as if it's physical stress and it's something like an injury or inflammation or disease, that's something that we have less control over. It seems to me. I don't know.
Right.
Am I making right? Okay.
No, you're absolutely right.
Okay. So if we're talking about then mental stress, like tell me more about what actually happens. So for example, I'm at work, I'm getting all these demands made on me. What is now happening to me in my brain, right?
Yeah.
If I'm not handling that well, I'm just not.
Yeah, that's a really good question. I mean, and it also is an opportunity just to introduce an idea that's floating in the stress world, and that is this concept of anticipatory stress. So that's kind of what we're talking about, right? That's when we feel stress, is when we anticipate something that's going to happen, and we don't know whether the outcome is going to be positive, and we always guard against a negative outcome. And so that creates in us this anticipation in our body, which feels like, it doesn't feel great. It feels like stress, right?
Right.
So when you ask people, do they feel stressed? That's kind of what they're talking about. They're in a situation, they're not certain about the outcome, and they're trying to figure out, how do I get the best outcome out of this? And that to them is really, really stressful, right?
Okay, so what's happening? Yeah, like what's happening with us then physiologically? Like what's going?
Yeah. So that type of anticipation activates many, many areas of the brain, but one of the key areas that it activates is a tiny cluster of cells, just a few thousand cells in a brain that has 10 billion cells, right? So you have a few thousand cells, and these cells are the stress command cells in the brain. So your entire stress command center is down to these few cells. And so these cells help contribute to changes in your heart rate and your blood pressure, but they also gate a number of different behaviors, and they release hormones. So the one that we know best, and we've heard about in the general media, is probably cortisol. Cortisol right. is the stress hormone. It does lots of fantastic things, right? It mobilizes glucose from stores when you need energy. It helps with wound healing. It helps with injury. It helps the immune system. So those are all great things. But cortisol needs to turn on when it's required, and it needs to turn off. And so often with repeated chronic stress, which is what we're often faced with, those cortisol levels just remain elevated. And that is not a great thing for us.
Why?
So cortisol has a number of effects on the brain. For example, it affects our ability to recall information, right? So our memory. So when we're constantly stressed, I think everyone can relate to this. You have a difficult time just finding that thing on the tip of your tongue, right? Like, so when you're stressed, little things like that are problematic. Cortisol in your periphery also has been linked to inflammation. It also has been linked to heart disease, to increased cholesterol levels. So it's doing a lot of other things in your body as well, and not just affecting memory and cognition.
Right. Oh, let me just stop you there then, because when you say linked to, heart disease and other not good health conditions, are we talking about strong evidence, like a strong evidence, a link between stress and disease, bad health?
Yes. Yeah. I think it's the evidence is very strong to support that idea. Yeah.
And is it mostly with like heart conditions or anything else?
Yeah. It's been implicated in a lot of things. Just about, I think we could probably classify them more generally as metabolic disorders. So a lot of metabolic conditions have been linked to persistent elevations in circulating cortisol in people, and things like heart disease have also been linked to elevated levels of cortisol.
Oh, okay. So the thing is, though, you were talking about turning it on, but important to have it turned off, right?
Yeah. Yeah.
Isn't it important though to turn it on sometimes?
Yes.
Yeah, right. Because we often we usually think about stress as being negative, but we all need some stress, right?
Yeah, no, stress biologically is actually, it actually has a lot of adaptive value. It helps you and every other organism that has a stress response. It helps you survive because it's the system, it's the response that gets turned on when there is a challenge or a threat. And so in many ways, an acute amount of stress, so an acutely stressful situation is good because it activates areas of your brain. It mobilizes, your body to do something, to be right. And so that's positive. It's there and it's persisted through evolution because there's a huge benefit to it. The challenge is that stress leaves what I'll say are imprints on the brain. So it changes how cells talk to each other in the brain. And these changes can then mean that it's very difficult for you to shut off your stress response. And we don't really fully understand what those changes are. And then stress also through those changes means that the next time you experience a stress, you may exhibit an exaggerated response. Your behavior may be different. And so all of these little imprints are being left in different areas of your brain and leading to slow change in how you respond to stress.
Oh, okay. I don't know if this is related to pain, but another interview I did with a doctor who talked about chronic pain was saying that when the pain system in your body is fired too often, and it becomes out of control, then it's really bad, because if the original pain was caused by an injury that doesn't exist any longer, but you still keep feeling that pain, it's as if that alarm system in your body keeps going off, keeps going off, keeps going off. I don't know if this is the same way. Are you actually damaging because of the overload of stress? You've damaged something. You're damaging something in your body.
Yeah. No, Mary, the analogy is perfect. What you're doing in pain and in stress is you're changing your threshold for responding to something. So in pain, for example, in neuropathic pain, just mere touch causes you to have a painful sensation. That's because what your system, whether it's in your periphery, like on your skin or in your brain, what's happened is there's been a reset of the system. Some plasticity has happened, a functional plasticity, so that what previously was not painful is now painful, right? And so the same thing happens with stress. And this has been demonstrated many, many times, that things that were previously not stressful, right? If you stress individuals over and over, now, previously innocuous things now trigger a stress response. And that, we think of in the way that I think about stress as a functional plasticity. And so that means something in that system has changed, something in the way that that system remembers information has changed. And we have this idea where we call there's a gain in the system. So engineering folks will understand kind of what I mean by gain in the system. And so the system just accelerates much more quickly, right, to stimuli that normally should be innocuous.
Oh, okay. So then here's the trick. So you said that some stress is good, too much is bad. How do we know when we've reached that whatever it is, that threshold where, we're going over the edge here, this is too much? How do we know that?
Yeah, so we often don't know that until it's too late. That's really the challenge. And one of the reasons we don't really know that is that these systems that I'm talking about, these stress systems, are controlled by areas of the brain that we don't have great conscious control over. So they're ticking away doing their thing. And we go on our giant human cortex, it's doing its thing, and it often doesn't understand what's going on inside our body. I think we're all terrible, actually, at understanding what goes on inside our body, and knowing how to take control of that and how to change that.
And you know what? One of the things that we didn't talk about, when we talked about how stress can lead to disease like heart disease and other metabolic conditions, what about stress and an overload of stress and its relationship to mental health disorders?
Yeah, this is really the big question, right? So the heart disease and the peripheral metabolic disease, those are all things that we can get good measures of. We can do a blood test, right? We can do an EKG. We can begin to understand the link between stress and those things. The link between stress and mental health, or how stress sows the seeds for the onset of mental illness, is something that is very, very challenging. So we can start with, we know that absolutely chronic stress can lead to very debilitating mental conditions. We also know that people who have been stressed can be fine, but then an intense stress can all of a sudden trigger an anxiety attack, right? Can trigger somebody experiencing symptoms of deep depression, right? That they're not capable of doing what they need to do. And so how stress does this, that's really I won't even say $1 million question. I would say the multi-billion-dollar question, because that's where it kind of takes it over the edge, right? So when anything starts to affect our mental health in this way, this is something that we really, really need to pay attention to. And so what's challenging is that a lot of these mental health conditions. Let's say anxiety. Anxiety is a good one. Mm-hmm. So we often link stress and anxiety, right? But the response, the anxiety response, which is, that your heart rate quickens and your pulse quickens and you need to get stuff done. That's good. But but only if it's controlled, only if it happens at the right time. And so stress, just like we talked about a few minutes ago, it kind of blurs that line, right? And so now you start to, rather than just having an anxiety response acutely, you start to generally show anxiety in situations that should not provoke any anxiety. Crossing the street, for example, right? Some people are debilitated and are unable to do very simple, what you and I might consider day-to-day tasks.
Mm-hmm. And just to complicate things even more, you and other researchers have done work about how stress can be contagious. Can you talk about that?
Yeah. Of course. Yeah. So we always think of ourselves as these kind of singular units of human beings, right? That my physiology is my physiology, my brain is my brain, your brain is your brain. We interact, of course, we have social interactions, we do all these things, but we don't think very much about how what we're experiencing inside us, meaning stress, could be affecting others around us. And so this idea of stress contagion, much like, you might get, a contagion that's a bacteria or something, a stress contagion. In other words, how does stress transmit from one individual to another? This idea has been out there for a little while. What hasn't been well understood is what is the underlying biology of this? Are we transmitting stress just by the way we act? So, for example, you can walk into a room and you can almost see the way people are sitting or talking, who is a little bit more stressed and who is not. Somebody gets up to talk in front of an audience and you can tell, you're like, that person's stressed, right? But it turns out that's not the only way that we detect stress. So we and many, many other animals, I think this is a very, very ancient and conserved signaling mechanism, transmit information about our internal states by releasing signals into the environment. So when I talk about internal state, I'm talking about stress. So that we call a negative internal state. And so we transmit chemical signals through our skin and through our sweat glands that are different when we're stressed than if we're just sweating, doing something else.
Yeah. Oh my gosh, that is so fascinating. And when you say so many other animals, that is so true.
Yes.
Like I think about, dogs for sure.
Of course.
And then even I've done interviews on ants. Even ants will right? Ants will, and wait a minute, even plants, even trees communicate with each other, right? When they're stressed.
100%, Mary. You just stole a slide from my talks. Yeah, that's absolutely right. So the oldest, you can see this, right? If you cut a leaf starts releasing signals, right? Which will either attract or cause insects or whatever to go away from it, right? To allow it to heal and things like this. Yeah, leaves do it, fish do it, reptiles do it, mice do it, dogs do it, and it turns out, and we've always thought, well, we don't do it. Actually, we do it. We're just not always that aware that we're doing it.
Okay, right. So you've got to talk about that experiment because you told me about that amazing experiment that was done.
Yeah. So this is a pretty remarkable experiment. It builds on a lot of literature on work that's been done in creatures like mice, but this experiment was done in people. And so I should credit the folks who did it. It's a group in Israel, and the lead author is a guy named Noam Sobel. And he's at the Weizmann Institute in Israel. And so what Noam and his group did was they took sweat samples from two groups of people. One group had exercised, so that's what I'll call the regular sweat. And the other group had gone skydiving. And so I think we can all agree skydiving is much more stressful than just exercising for most people.
Okay, was it their first time skydiving? Because that would be really stressful.
Yeah, I think that would be. Yeah, that I don't know. Anyway, so they took the sweat, and then they kind of put drops on towels, and they asked people whether they could detect a difference in the smell, and people have no problem detecting a difference in the smell of those two sweats. So that's interesting. But what's really, really interesting in this study, there are two pieces that are super interesting. One is that when they then take these people, their test subjects, and they put on a heart rate monitor and they measure their skin galvanic response, how sweaty their skin is and their breathing. When they put them through a battery of cognitive tests and decision making, what they find is that when these people are asked to do these things in conditions in which they pipe in through the ventilation some of this stress sweat smell, but they do it at a level that people are not consciously aware of it. When they do it,
they don't know they're smelling it. They don't know they're smelling it.
Right. They don't know. If you ask them, do you smell anything? They say no. But their body knows. So their body responds in a way that they're being exposed to something different. And their brain, in terms of doing these cognitive tasks and making decisions, responds like it's being stressed. So
wait a minute. That was only with the skydiving sweat?
Yeah,
not
only with the
other sweat.
Not with the other sweat.
Not with the regular sweat.
Right. And so as a scientist, that tells me a lot of things that are really interesting. So one of the things that it tells me is that the way that we detect this through our nose, right? The cells in the nose are connected to these stress areas in ways that probably bypass our cortex, the part that processes conscious, right? That tells us what's going on.
Right.
And that's because evolutionarily, these systems, your olfactory system in your nose, your hypothalamus, which is where your stress cells are, those evolved very, very early. The ability to detect the chemicals in the environment and the ability to release signals, right, that tell others about what's going on inside you evolved very, very early, well before organisms had a cortex.
Okay. Wait a minute. Before we had a cortex?
Yeah.
So what were we when we didn't have a cortex? We weren't humans. Is that what you're saying?
Yeah. Well before we were humans. Yeah. Well before we were humans. Oh my goodness.
Okay.
Yeah. We're talking like single multicellular organisms when we were like globs, right? So there's a fascinating literature around how social behavior evolved, and I think it's relevant to this discussion. And there's an argument that social behavior evolved originally when cells under duress would release chemical signals to attract other cells to help protect them, right? And that was the first kind of piece of evidence of quote unquote social behavior.
That's the first evidence of community.
Yes, if you want to put it that way, yes. Yeah.
That is incredible.
Yeah.
So these people were not aware they were smelling anything.
Correct.
And yet you're saying their heart rate went up, their breathing went up, like these different markers, right? To show that they were stressed. Okay. Yeah. This is what's also interesting about that though, is you said that the concentrations were very low, like, right? So low that they couldn't detect it. So if you were to apply that then to the real world, I'm walking around and I may be in a room with someone else who's just near me, who's very stressed, right? I'm not even talking to them. I don't know them, but I might be getting a signal of stress that is passing my cortex, right? And maybe my heart rate's going up. I don't know. Maybe I'm starting to breathe quickly. And I'm wondering, well, why is that? Like, what's going on here?
Yeah, I think you may very well be doing that. I'll just throw a caveat in there. In our social spaces, there are a lot of odors. There's a lot of odor mixing that happens. So we smell a lot of stuff. You can smell lasagna baking. There's coffee. Somebody walks through, and so your ability to discern that may not be so great, right, as it is in an experimental setting.
True enough.
But having said that, if a loved one or a partner were to come home after a really tough day, I bet really quickly whether they had a hard day without them saying anything. You can sense it, right?
Mm-hmm. Yeah.
So I always ask, well, what is that ability to sense? What are you sensing? And everybody says, well, I don't know. And so is it maybe that you're detecting a signal that they're
Something?
releasing,
Yeah.
but you don't know what it is?
Okay, so now I'm going to go back though to what we said earlier about many people today feel that they are very stressed, right?
Yes.
So now if you have many, many people in society,
Yeah.
in your community, feeling
Yeah.
very stressed, and you're now interacting with them on a daily basis, right?
Yeah.
What does that say? Now what's
Yeah.
going on? If stress is a contagion, does that
Yeah.
mean then there's this kind of, I don't know, if you were to graph it, does it become sort of exponential where we're all now catching it? I'm just kind of wondering what's going on then. That's
I
true.
know. I know. You think about, like, are you creating this feedback loop?
Mm. Yeah.
That one is just, jumping. It's almost like ripples, right? Like you drop a pebble and then it just ripples and ripples, and yeah. So is it starting to do that, right? I think it's an intriguing thing to think about. I wouldn't say no, but I can't say yes. So I
Yeah.
really like the idea as a scientist. I hate the idea as somebody living in this society.
Mm-hmm.
So, yeah.
Okay. And then the other thing I think of though is, why just stress? I mean, if stress is having this effect, where we can smell it and it's affecting us in some biochemical way, why not joy? Why not joy? Did anyone study joy and say that, oh, that's in our sweat too?
Yeah.
And that's like a contagion. Like, why would it end at stress?
This is a great question, and this is a question we are fascinated by. We would love to know how you transmit happiness, right? Because that would be amazing. So I'll tell you about one experiment that shows maybe it's possible, and then I'll tell you why I think stress is more likely to be transmitted than positive things. So I think there's one experiment so the experiment was done in mice, and they took two groups of mice. In one group, they water deprived them for a few hours, and then they gave them water. So they were, I wouldn't say they're happy, but they're relieved, right? And so you have that mouse, and then you have another mouse. And then if you introduce a test mouse, it goes to the relieved mouse more often than it goes to the neutral mouse. And so there's something in the cortex that draws them right to this mouse, and they don't know what that signal, that communication is. So there's something about having this relief or
Wait
happiness.
A minute. Okay, hold it. They go to the relieved mouse more than the mouse who has not had water.
Correct. No, but the other mouse has had normal water. This was like no water, and then they give them water. Right. So you're like,
and the other mouse has had normal water.
Yeah. The other mouse, just a normal mouse.
That's okay. That is interesting too. But they haven't done it on humans.
No,
they haven't tried anything like that on humans.
No, but I think, that there's a reason for this. And that is that negative signals like stress, are very important, right? Because they're critical for our survival, that we interpret them correctly. And that our ability to pick up that signal that is evolutionarily released when an individual is under threat, that allows us to maybe learn from that without experiencing the threat itself. So it has huge adaptive value. Whereas positive signals, although great, don't have the same type of survival value that being able to avoid a negative signal does. So I think in humans, I have no data to support this, and maybe there's data out there that I'm not aware of, and I'm sure somebody will say there is. I think in humans, one of the best ways to transmit joy is laughter. I think it's an amazing, amazing thing. And I noticed this when we came back after the pandemic and we started to have meetings with others and we started to gather. The one thing that struck me was when you sat around a dinner table with a number of people that you hadn't spent time with, is how much people told jokes and laughed. And that didn't happen during virtual Zoom in the same way, because you need people to talk over each other and laugh over each other to create this kind of positive feedback.
That is a really interesting observation.
Yeah.
So, okay, Yeah, and I see your point, and that sounds very convincing about what you're saying. That stress signaling would be evolutionarily more important than signaling joy. I can see the
Right.
value of that. Yeah.
Yeah.
But you know what? The other thing too is, I mean, what determines how we as individuals react to stress?
Right.
Like there must be a genetic component, maybe. Like I don't know. Even as you know, when we're born
Yeah.
right? We have certain kind of
Sure.
personalities, and
Yeah.
how would that play into it? Right?
Yeah. There's likely a genetic component to it, but there's also a huge experience component to it. So those who have been able to manage stress or be faced with stress and have positive outcomes from that stress, right? So they
Right.
managed it, they did something, it worked out, everything was great. If you do that repeatedly, you start to train your brain. And so that ability to control the outcome for stress trains your brain so that regardless of other stresses that you face, it doesn't even have to be the same stress. You end up responding really well to it. Whereas others who are faced with stress but don't have good outcomes or feel like they have no control over the outcome of the stress, they start to develop a phenotype because there are changes going on in your brain. They start to develop a phenotype where other stressors really have marked negative effects on them. And so there
Did
is
you did you say that's key early on? Is that what you said? Did you say that can play a huge role early on?
in our development, you mean, or when we're
Mm-hmm.
children? Yeah, I
Yeah.
don't know. I don't know if it plays a role early on or not, but for sure it plays a role in the way that we handle stresses. Yeah, and you could imagine early on would be really a critical time, right? Because this is when the
Yeah.
brain is very plastic. Things are not yet, fixed and set in stone. A lot of changes can happen, right? So creating positive. I won't even say positive. I'll say challenges in
Mm-hmm.
which the individual has strong control over the outcome can be really beneficial.
Okay, so what does that say about parenting? To me, I think that says a lot, because if you're saying that it's key when we're very young to have those challenges, so we learn how
Yes.
to deal with them.
Yes.
We can have a successful outcome. We feel control over them.
Yeah.
You know, there is a kind of parenting where you're very protective over your child. You know,
Yes.
and you think of the child. This is you think it's in the best interests of your child to take away stress, right? To
Yeah.
protect them from
Yeah.
negative things. And yet now, what you're saying, that may not be a good thing.
Yeah.
That may not be
No.
a good thing.
No. I don't think it is. I think then
Okay.
you're not prepared when you become an adult. You haven't had the right training. We do all sorts of training for everything else. We do training for sports, for your kids playing hockey, for your kids playing basketball. You put them in all these situations in practice or during training so that they're ready for the game, right? So for the game of life, which is going to be very stressful, right? So it's really a great question. How should we be preparing our children, right? Should we be throwing little challenges at them in which we've kind of rigged the game so that we know the outcome is going to be largely positive, right? So
Mm-hmm.
you let them get the win, not immediately, but maybe having to work through it, right? I think that might be beneficial. I'm not a psychologist, so I'll just throw that caveat. This is just what I know about how the brain works.
Yeah.
But
Yeah.
I think,
No, that totally makes sense, because, you know, if you end up shielding children from those challenges, and the children don't experience stress in that way, then what happens when they do as an
right,
adult? All of a sudden they're faced with some huge stressful challenge, but they haven't coped with that
right,
all that
right,
time.
right. And I think this is anecdotal, but many parents will say this in their kids, that when their kids begin to master difficult things, they can just see the confidence in them. Parents say this all the time, right?
Mm-hmm.
You can see that grow, and being able to master one challenge usually makes you more adept at other challenges.
So then what can we do? I mean, if stress is so pervasive today, this psychological kind of stress that we're talking about, what can we do to mitigate it, to make ourselves, I don't know, maybe more resilient to it?
Yep. Yep. That's exactly what we're trying to do, right? Is to try to come up with strategies to increase resilience, to increase our ability to cope and manage the stress in a positive way, right? Which means don't reach for the bag of chips and, the carton of ice cream. I mean, it's fine once in a while, but maybe don't make that your go-to every evening. But I think that, there are certain things, and when I tell you, everyone's going to agree on this. Like, for example, physical exercise is a good thing because it causes a lot of changes that we don't fully understand that appears in some situations to help mitigate the effects of stress. So that's a really good thing. Doing other things in your life that are challenging, but over which you can control the outcome is a really good thing, right? That helps you then deal with other challenges in a way we don't really understand. So those are all really positive things. The other thing that I always refer to, even though we talked about social contagion of stress, is that positive social interactions are really, really important in helping buffer the effects of stress.
Positive. And when you say positive social interactions, do you mean in person or any kind, like even on Zoom, or is there a difference?
I don't know if there's a difference. I always reflexively go back to in person is always the best, just because I think we receive so many additional signals from people. And I think positive social interactions with many, many people are terrific. And I think there's a huge benefit. Even in experiments with mice, you can show things like this, that social interactions can help mitigate the effects of stress. That's absolutely true. So I think that there is something there.
And what about, now I know this isn't necessarily your area, but what about therapy? What about using strategies? I don't know whether it's, CBT or other kinds of therapy to help you cope with the stress or impending stress, that anxiety, you feel.
Yeah. No, I think they're great. I think for us, we're not like a collection of, genetically similar individuals, like a colony of mice might be. We're all unique and we've had unique experiences, and the way that we respond and the treatments that we respond to are going to be very, very different. And so I think there's a huge role here for behavioral therapy. For example, presenting challenging situations in which you can have a positive outcome. That can be part of a behavioral therapy, right? And presenting that to an individual, helping them get through that, and then whatever else they face in the world, they feel like, this is manageable. I can do this because I could do this difficult task.
What about, and I guess this is the trick, isn't it? What about looking at the stress and whatever, is causing this stress, but looking at it and wondering whether it really should cause stress? Do you know what I mean? Not sort of taking it at face value every time and thinking, this is stressful. This is going to cause me stress. I'm going to get upset and I'm anxious. But now saying, you know what? This shouldn't be causing me stress. This is not a stressor. Like actually, and then now I'm getting into this area where what is real stress and what, what maybe isn't real. I don't know. Like it's a tough one, right? Because that's a tough one.
It's a really tough one. When our I'll give you a personal anecdote. When our kids were little, my wife would say to them when they'd make a fuss, when they were really babies, she would say, "Is this a fussable event?" And I, so I think there's a little bit of that in it. But the flip side is this. I'll tell you this: when I am asked to present or give a talk, if I'm not a little stressed, I know I'm not going to do my best. I just know that, because you need to be just a little bit higher than your normal function. You need to be like, we see some internal arousal. You need to be ready to go. And that is also part of the stress response.
I know it's so tricky because I almost feel as if that's what being, or at least part of being alive is.
Yes.
You feel alive when you're stressed, right?
Yes. You need to feel that. Yeah. If you're too chill in those situations, you just can't, like, you have suboptimal performance, right?
Yeah. So, okay. And what about your research then? Like, tell me about what you're really interested in right now.
Yeah. So we're interested in, we kind of break our research down into three kind of main themes that we're interested in. And we've touched on, I think, all of them in our discussion. One of them is trying to understand how the brain adapts to stress. And by adapts, I mean, what are the changes that happen at the cellular or molecular level that change the way different areas of the brain communicate with each other, change the way our brain sets the level for stress, so the threshold for stress, which is something we talked about. And then can we, by understanding those changes, can we leverage those into different types of treatments, right? So one of the things our work is starting to show is that after a stress, you have a window, and we call it this kind of window of opportunity, during which the system is still not back to normal, but you can intervene. You can do different things in that time. And that might help mitigate the long-term negative consequences of stress.
And what
So
do you
that's
mean by intervene? Like, intervene how?
So
Do you know?
intervene either through experimental manipulations in the types of experiments we do, which are probably not appropriate for humans, or things like exercise, or things like providing a
Oh,
reward, a rewarding stimulus, right? And so it's not a distraction. It's actually causing changes in your brain, which are almost opposing or rewriting what stress has done.
I
Right.
see. Yeah, yeah.
And yeah. And so, and social interactions actually is very similar in that window after stress. So that's one of the things. The second thing,
Wait a minute.
we're
Can I
folk.
just stop you for a
Yeah,
sec? Because
of
I'm just
course.
thinking about what you're saying. That kind of makes sense because you know how it could happen where you're in a situation, maybe it's even an argument or something, and
Yeah.
you're getting really stressed by it talking to someone. But then
Yeah.
all of a sudden, somebody will interrupt you, someone
Yes.
you really like, let's say, and
Yeah.
then you'll start talking, and then it's as if your mood just changes right away. Like now you're
It's,
reacting to that person. Do you know what I mean? Like,
yeah. Yeah. But had that person not come along right then, had you finished your argument, stewed on it for 20 minutes, and you saw that
yeah,
person an hour later, it wouldn't have the same effect.
that's right.
Right?
Yeah,
You would have had
yeah.
you would have had that argument reverberating in your brain, and that would have been
Yes.
causing, right, leaving little imprints.
Leaving imprints. It would have sunk in somewhere deep, maybe. I don't
Yeah,
know.
right. The second thing we think a lot about is the idea around controllable outcomes during stress versus uncontrollable outcomes, and how that changes different areas of the brain and different connections in the brain to make one more or less responsive to future stressors. So that's the second part, and then the final part we talked on was stress contagion. Really
Right.
thinking about how are these signals, which are detected by the nose, how do they end up at these cells in your brain that control the stress response? What are the connections? Can we understand or modify those connections? Can we change the threshold for the sensitivity to stress and things like that?
I want to end off with one thing looking at the future.
Yeah.
What is one discovery regarding stress in the brain that you feel is like it can happen? It's on the horizon, and this is the discovery that is going to be a game changer. Like, what would that be?
Oh my goodness. What a hard question.
Oh, is it? Wait a minute. Is it because there is nothing that looks like it's on the horizon, or?
No, it's just because the field is so vast. I'll tell you something that's really interesting and weird, and I don't know if it's entirely true or not yet. So,
Okay.
so, so, we know that there's this very close connection between our body and our brain, right? And we know, for example, that when we're sick, right, that triggers, let's say, an immune response, and that can affect our brain. We know, we don't quite feel well, we don't quite think straight. We know that, right? And so
Yeah.
we know the immune system and the stress system talk to each other. What we're beginning to learn now is that different types of stress can recruit different types of immune responses. So that, to me,
Okay.
is pretty
Give me an
wild.
example. Yeah. Can you give me an example?
So there are different. It's going to get very complicated into immunity, which I
Oh,
don't. Yeah. So largely that, I'll put it very simply like this: acute, very intense stressors that trigger a fight or flight response, that trigger the release of things
yeah.
like adrenaline in our body. They
Yeah.
will recruit one arm of the immune system, whereas the longer chronic stresses that cause a big release in cortisol will trigger another arm of the immune axis. And so I think we're just starting to
Oh,
understand brain immune in a really cool way. A great example of this is in university. After exams, I always used to get sick, right? Because
yeah.
you have this massive challenge that you get through, you need to get through. And then once that's done, your body goes, okay, we need,
Yeah.
right. Then you get your cold. Then you get, a few.
Exactly. And,
Yeah.
and so really, if I mean, again, this is all hypothetical, but could it possibly be because your immune system is on guard during that whole time? And then when you relax, it's got to relax because it can't be on guard 24/7 forever.
That's one possibility. The other
Oh,
possibility is that the cells in your brain that control your stress response
yeah.
are in fact dampening down your ability to generate a sickness behavior.
Oh,
So
it's
there,
dampening down.
so
Oh,
there's a very tiny and very new literature that is emerging on this idea, saying that these same stress cells that I talked about, these
yeah.
few thousand cells, also gate sickness behavior. So it's,
Well,
yeah,
this is fascinating. Okay. So
right.
that's an emerging field that
Yep.
you're excited about.
I'm super excited about this. Yeah, really.
Well, I'm pretty excited about everything you talked about. Thank you so much, JD. Well,
Thank
what a
you,
great
Mary.
discussion. Loved
Yeah,
it.
I loved it. Thank you.
That's Jaideep Bains. He is a neuroscientist, director of the Krembil Research Institute, senior scientist at the Krembil Brain Institute, and professor in the Department of Physiology and Pharmacology at the University of Calgary. We hope you enjoyed our talk on stress and the brain. And if you'd like to know more about Jaideep's work, please check out our show notes. That is it for this edition of the Cram Podcast. Please follow us on social. Our handle is @CramIdeas. Thanks for joining us and see you back here next time.